Hello everyone, welcome to Introduction to Data Mining class. In this unit, we will talk about basic statistical descriptions of data. Before performing analysis on the data, it is essential to better understand your data. In statistics, we typically describe a data attribute on the basis of the measure of central tendency and the measure of data dispersions. We can also visualize these measures using graphical representation such as box plot. Central tendency measures the location of the middle or the center of the data distribution. Commonly used central tendency measures include mean, median, and mode. Mean is the average of values, which can be calculated by taking the sum of a set of values divided by the number of values in the set. Median is the middle value in a set of values, which is typically obtained by sorting the values in the set and take the middle value as median if the number of values in the set is odd. Otherwise, the average of the middle two values is calculated as median. Mode is the value that occurs most frequently in the data. On the screen, we'll illustrate three frequency curves of a unimodel. The middle graph represents the symmetric data distribution, where the mean, median, and mode are all at the same center value. Data in most real applications are not symmetric. They may instead be either positively skewed, as shown on the left, where the mode occurs at a value that is smaller than the median, or negatively skewed, as shown on the right, where the mode occurs at a value greater than the median. Once we locate the middle or the center of the data distribution, the next step is to measure how data is spread. Commonly used measures for data dispersion include range, quartiles, and interquartile range, variance, and standard deviation. The range of the dataset is the difference between the largest and the smallest values in the dataset. The commonly used quartile measure is Q1 and Q3, which is obtained by dividing the sorted dataset into 4 equally sized consecutive sets. Q1 indicates the first splitting point located at 25th percentile, and Q3 indicates the third splitting point located at 75th percentile. The measure of interquartile range, IQR, is defined as the difference between Q3 and Q1. Variance and standard deviation are measures of data dispersions. They indicate how spread out of a data distribution is. A low standard deviation means that the data observations tend to be very close to the median, while a high standard deviation indicates that the data are spread out over a large range of values. To visualize the data distribution, we collect 5-number summary, which include minima, Q1, median, Q3, and maxima, and depicted them in the box plot. If any value higher or lower than 1.5 times of IQR, we can consider these values as outlier. This is an example of box plot. As you can see on the screen, the box represents the Q1, median, and Q3, and the height of the box is IQR. The two lines outside the box further extended to minima and maxima values. For outliers, which are higher or lower than the threshold values, will be plotted individually as the dot. It is worth mentioning that if a data attribute is a normal distribution, also known as bell curve, the mean is the center of the data. Mean is typically represented as symbol mu. In addition, standard deviation can be used to describe how the dataset is spread. Standard deviation is typically represented as symbol sigma. Basically, 68% of data objects in the entire dataset is between mean minus 1 standard deviation and mean plus 1 standard deviation. 95% of data object in the entire dataset is between mean minus 2 standard deviations and mean plus 2 standard deviations. 99.7% of data objects in the entire dataset is between mean minus 3 standard deviation and mean plus 3 standard deviations.